Hello, and welcome back to a video series on MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video number 25 in the series on function operations. So in the last video, in fact videos, we talked about the geometry of functions. We talked about properties of their graphs, things like increasing or decreasing values, maxes and mins, etc. In this video, we're going to get back into algebra. We're going to talk about the algebra of functions, different operations that we can do with two functions. Remember, an operation of numbers is something that takes in two numbers and gives us a third number back. In the same way, operations on functions will take in two functions and give us a third function back. So let's take for this entire video two examples to be our leading examples. Let's say f of x is x squared and g of x is x plus 2. The first thing that we're going to get into is function arithmetic. How do we add, subtract, multiply, and divide not just numbers, but whole functions? Well, the answer is going to seem pretty simple. We're going to follow our intuition from numbers. I'm going to take the functions as whole objects, and if I want a new function, which this function is called f plus g, right? It's f plus g of x. Well, what do I do to get that? Well, you just add f of x and g of x together. So this might be the new third function's name, f plus g. How do you get it, though? You just add the two functions together. No big deal. So for example, for our two functions, that's going to be x squared plus x plus 2. We take f and we add g to it in terms of their rules. We take the rules for f, x squared, the rules for g, x plus 2, and we just add them together right here. Subtraction works the same way. If you want this new function, f minus g of x, that's f of x minus g of x. You take the rules for f of x, x squared. You take the rules for g of x, x plus 2, and you minus the rules for g of x from f of x. We could distribute that minus sign and say this is x squared minus x minus 2. Now, I want you to note that like numbers, subtraction is order dependent, right? It matters whether this was f minus g or g minus f. But also, like numbers, you would just get the negative if you took and changed the order, right? Remember, a minus b is the same thing as negative b minus a, and the same is true for functions. Try that out as an example if you don't see it immediately and prove it to yourself. And also, consider about switching the order of addition. Just like the addition of numbers, the order of addition of functions doesn't matter. Multiplication is going to be similar. If we want to multiply two functions and get this new function f times g of x, we just take f of x and times it by g of x. So for our two functions, that just looks like this. Could you distribute and get x cubed plus 2x squared? Yeah, totally. But I just want you to see this is just taking f of x's rules and multiplying them by g of x's rules. Division is also similar. If you want f over g, or f divided by g of x, that's f of x divided by g of x. And that's no different than taking f of x's rules and putting them in the numerator, and g of x's rules and putting them in the denominator. We will culminate this series with rational functions, and we'll talk a lot more about things that look like this. Now, notice, like numbers, this denominator cannot be 0. And so, in other words, your g of x cannot be minus 2. That's something weird here, right? Like normally, a number is either equal to 0 or it's not. Here, g of x could be 0 if x was minus 2. And so something about that has messed with the domain of this quotient function. We'll talk a lot more about that in the rational functions section. For now, I just want you to notice that there is an issue with dividing by 0 here that we're going to have to be conscious of, and that the quotient is not the same thing if I'd flip them. You get something very, very different when you take the reciprocal here. Moreover, if I have f times g, that's the same thing as g times f, because it comes down to multiplication of variables, and that should also be commutative. So now I want you to write down this first part as critical notes. The definition of function arithmetic, or function algebra if you like, right, is going to be given as follows. If you want to know what their sum is, you just take the sum of their rules. If you want the difference, you take the difference of their rules. The product of their rules. And the quotient of their rules. We need to be careful with quotients about dividing by 0, but we're going to hash that out a lot more fully later on. Now, all of this was kind of boring because it all seemed exactly the same way that things worked with numbers, except maybe not for division. That one had a little bit of nuance to it. But there is something that we need to talk about right away that doesn't have an analog with numbers, right? That only functions could do, which is called the composition of functions. Composition of functions, which is written FOG of x. This symbol here is called circ, but we usually say FOG of x. Now, provided that the range of g of x, the output values from g of x, are play nicely with the domain of f of x, you don't plug in any forbidden values here, then you really can just plug the whole function g of x in as the input to f of x. Let's see what that looks like in terms of our little function machinery here, right? G is a function. It takes an x and it spits out this g of x object. But then we're going to take that immediately and boom, just plunk it on in to f as a machine itself. And then that's going to do something to g of x, not to x, right? But to g of x, and then spit out this thing that we're talking about, FOG of x. Let's, well, first of all, a perfectly equivalent way of writing these, and that I think does a lot more to tell you what's going on than FOG of x, is this one. Here I've plugged in g of x into the parentheses of f of x. And remember what parentheses mean for functions. They tell you where your input is. So this thing says that the input into f of x is g of x. The input into g is x. So we say that g of x gets plugged in to f of x. Okay, so let's look at that with our example. F of x is x squared and g of x is x plus 2. If I say FOG of x, you should immediately rewrite it as f parentheses g parentheses x parentheses parentheses, right? G of x is getting plugged into the parentheses of f. What is g of x? It's x plus 2. So what do I do? Well, I follow f's rules, but now applied to g of x's rules, x plus 2. I do x's rules, x is x squared, f is x squared. So I want to square x plus 2. Voila. Now, I want you to note that this is a place where order is really going to matter. Order, meaning if I go GOF or if I go FOG, right? These are in general not going to be the same thing as each other. Let's calculate GOF in the same way that we just did FOG. GOF is G with F plugged inside. F is just x squared, and G says take your input and add 2 to it. So I get x squared plus 2, which you could definitely see, I hope, is not the same thing as x plus 2 squared, right? Just plug in 0, right? One gives you 4, the other gives you 2. They can't be the same. So now I want you to copy the definition of composition in terms of substitution into the function's input slot as your critical notes here. Copy this down. So now it's time to try some of the praxis exercises. Let's take f as 3x plus 1, f of x as 3x plus 1, g of x as 2x minus 1. What are their sum, difference, product, and quotient as functions? What is their composition, both FOG and GOF? And what is f of 2? So pause the video at this time and see if you can figure that out. All right, let's see how you did. So in the first case, we have summing them. Well, the negative 1 and the positive 1 cancel. We just get 5x. Taking their difference, we have to be sure that we minus this minus here to give me x plus 2. Here's their product. If I FOIL that out, we get 6x squared minus x minus 1. And I won't do anything more with this quotient other than just write it this way. For the second one, if I plug g of x into f of x's rules and simplify, I get 6x minus 2. If I plug f of x into g of x's rules, I distribute the 2, I simplify, I get 6x plus 1. And if I compose f with itself, right, if I plug f of x's rules into f of x, I get 3 times f of x's rules again, 3x plus 1 plus 1. And so simplifying that, I get 9x plus 4. So what is f of 2? Well, just replace this x with a 2, and we get 22. All right, that's it for this video. Thank you for your patience. Have a great day, and good luck with your studies. I'll see you in the next one.